go through 8.5. I know you've done the first few with me, but I need to kind of do this for the video presentation for the fans at home. And yes, there are fans at home. If you haven't subscribed to my YouTube channel, as a favor to me, I got to get to 1,000 subscribers. So, you know, I'm up to 48 right now. No, I got to get to 1,000 subscribers in 4,000 hours. I thought it was 4,000 minutes. It's 4,000 hours of watched video. Yeah. I was like, okay. So, you know. You know what? Every day before I go to letter of recommendation, you better be a subscriber. I'm telling you right now. Ain't no letter of recommendation if there ain't subscribership on your part. Yeah, okay? And you gotta watch math videos for a long time. Okay? I better be getting like 1 million views just out of the two of you. You know.
Every day I just like go to sleep, put like 9 of your videos.
Yes.
I got you. I'll
do that for like the rest Thank you. Thank you. My retirement will appreciate it. Okay? Yeah. Then I'll be a famous math teacher driving around Lamborghinis, you know.
Making diss tracks on your
yeah, it'd be like, let's do some math. What? Yeah, it is. Oh, yeah. You're watching my dad videos. Okay, folks. Remind me what we need to do with the 3.
Put it up.
Yeah, I know we did this one already, okay, but I didn't get it recorded, so
make it the exponent. Put it up to the 2.
Okay, all right, so we make it an exponent, right? So we got log 2 to the 3rd plus log 9, which we know is the log of 8 plus the log of 9. Now, the property about addition is a lot like, remember when we had something like this long time ago, x squared times x cubed? What did you do with the exponents?
Added them.
You added them together, right? 2 plus 3. Yeah. He wants to be famous. That way, you know. So, yeah, because everybody will recognize his voice. Now, so the addition property of exponents goes with multiplication. This is the exact same idea. So what are we going to do with the 8 and the 9? Multiply them.
Now, why would you bring addition into the example and then...
Okay, because I'm trying to illustrate a point that when you are multiplying like bases, you add the exponents. Well, what is a single word synonym for logarithm?
Exponent.
Exponent, thank you very much. So when you are adding exponents, here's an exponent and here's an exponent. When you're adding exponents, it goes with the idea of multiplying the bases. Thank you very much. So log 72 is the answer to the question because they only asked me to write it as a single log. They didn't ask me to evaluate it. What does evaluate mean? They would actually want an integer or a decimal or a fraction if they were asking me to evaluate, but they didn't. Okay, now, log base, so I see subtraction here. Oh, but I better handle that exponent first. I forgot. What am I going to do with the 2? That's right. Make an exponent. Right. So now we got log base 3 of 81 minus log base 3 of 3 squared. What is 3 squared again? That is a good question. Okay. Come on. 3 squared. What do we got?
9.
Thank you. Oh, sorry. I was listening to someone try to make jokes in the back. So what are we doing with the 81 and the 9? Because we see subtraction. We're dividing those two things, right? Okay, and yes, folks, we do put the first one in the numerator and the second one in the denominator. And what is 81 over 9? 9. So we have log base 3 of 9. This one does say evaluate. So if you don't know what that is, I have always suggested to you that you set it equal to x and change it to its exponential form. What's the base? 3. The base is 3. It says so right there. What's the exponent? X, right? Because we know that logarithm means exponent. That leaves me with 9 for the other box. Can you tell me what x is? 2, thank you very much, right? The exponent on 3 that gets me 9 is 2. All right, which one of those is the correct? Log of the argument over log of the old base. Log old base. And yes, you need to know that. And that is choice B. You're right. And of course, we're changing it to base 10. Why do we change things to base 10 when we use the change of base?
Because it's in our calculator.
Because it's in our calculator, and we can use the calculator to come up with the weirdo decimal. Because ain't nobody in this room know what the power is on 3. Whoa, don't do that. Nobody knows the power on 3 that gets me 13. It's some weird decimal. That's why we use the change of base theorem, so that we can evaluate those weird decimals. Okay? So, since we see division, how are we going to split this up? 2 logarithms with what in between? Subtraction, right? What's the first logarithm? Log base 11 of 11. Log base 11 of y. But it does say to simplify it as much as you can, and there is one thing you can do, and that's right here. What is that? What's the exponent? The exponent on 11 that gets me 11. 1, thank you very much. So, and I have no idea what the other one is, so I'm leaving it alone. All right? There's my final answer. That's as simple as that one gets. What if it had said log base 11 of 121 over y? It would have been 2 minus log base 11 of y, right? So, I know it's not. Yeah, I'm hoping she's okay. Yeah, that would be suggested. Okay. So, first thing I see is subtraction. So, what 2 logs am I going to split that into? When I see the division, I know I need to split it into subtraction. What's the first one? Log base b of x cubed times y, and then on the other one I have log base b of the denominator z cubed. Okay? Now this one has multiplication, so I can split this one into 2, separated by what? Come on, multiplication splits into what? Addition. What? Hey, stay with me. Talking about your absences. That's great. All right, now. This is not quite expanded form, because expanded form, we said, has exponents which are 1s. Right? There's a 1. That's a good exponent right there on the argument, but the other 2 are not. What are you going to do with them? You're going to move them in front of the logs. Thank you. Yes, sorry. Sound effects. It helps me. Oh, yeah? Yeah. Can't say I haven't heard that one before. Okay.
Is that gossip?
I think that's on video. We can report it.
Like you'll think you're passing the class, and then at the very end, bam, because it doesn't.
That's pretty much out.
Okay, folks. You need to change it to its log form. So we need to know the base, we need to know the argument, and we need to know the exponent. Log base 2, thank you very much. What is the exponent? Okay, remember that the exponent is on the other side, right? And then that leaves me with one thing left, 31. Okay? Now this is one way to handle this question. I remember showing you 2 different ways to handle this. So we could immediately change the base, right? Log 31 over log 2. equals 2x. Now remember, this is 2x over 1. So you can think about this as a proportion if you want. Take your calculators right now and give me this decimal, because it's going to be a weird decimal. It's not going to be normal. It's not going to be something that off the top of your head you can figure out. Okay, so use your machine. So what'd you get? 4.95, good enough. Okay, we know it goes on for a long time. All right, but that's good enough. All right, so what do we divide by to end this problem? Divide by 2, okay? And if we divide by 2, we end up with our final answer. And sorry that this bled over into the other question. 2.48, something like that. Okay, how do you know you're right? You can plug it in. Folks, if you're going to check your work, and I know that none of you like to do this, but what I would do is this. Not for this one. You could guess and check if it's like the one question when you were talking sequences and series, and it was, 3 to the x equals 729. Yeah, you could kind of guess and check on that one. No, I'm not letting you guess and check on this one. All right? I don't want to sit there and see, and they just keeps getting it. If you don't show me any of the work and you write down 2.48, you immediately lose half credit. Maybe even 3/4 of the credit. I mean, seriously. It's not that hard. You got your notes, for crying out loud. Okay? Now, where have you been? Yes. That's why I keep telling you to take notes and use them. Get out your notes. Why do I say get out your notes and we're doing it? Never mind. What? Okay. Well, I'm actually going to show you another way to handle it, because I did another way in class, and some of you like this way. So you can take the logarithm of both sides of this equation. So the other way to handle this would be to take the log of both sides. And I know that some of you actually did this, so that's why I'll remind you. And then what can we do with this exponent? We can move it down to the front, so we can make it a coefficient. Now, what are you going to divide both sides by? We want x to be by itself. 2 is one thing that we are going to divide by, and the other thing that we're going to divide by? Log 2. So 2 log 2. Now, if you're going to do this, I would recommend you use parentheses around your denominator. 2 over 2 is 1, and log 2 over log 2 is 1. You will get the exact same result, 2.48. I don't care which one you like or which one you use. Pick one. Whichever one seems easier to you, use that method. Okay? Question 2, all right. Is this a single logarithm? Is it a single logarithm?
Yes.
Yes, it is. If it's a single logarithm, you are ready to change it to its exponential form. What's the base? What's the exponent? What's the argument that it equals?
10.
The base is 10. That's true. What's the exponent? 2. Remember, log equals exponent. Log equals exponent. Okay. 116 minus 4x is the last remaining thing in the bunch. Okay, so I'm sure you know how to find 10 squared. Probably know it already. 100, right? Right, so we have 100, and then of course we're going to move that to the other side, so we're going to subtract 116. All right, so we got negative 16 equals negative 4x, and then what? Divide by negative 4. Okay, and then we're done. Good. So x is 4. Oh, because remember when there's no base written, that's called a common logarithm, and we automatically know it's base 10. Okay? Okay, the next one is also base 10. Is this a single logarithm?
No.
No, so you need to make it a single logarithm. So you're going to use your property. What are you going to do with the 3x and the 1x? We're going to multiply them. You were right the first time. Stick to your guns on this. Okay, so 3x times 1x gives me what? 3x squared, right? That equals 12. Is it a single logarithm now?
Yes.
So we are ready to change it to its exponential form. What's the base? What's the exponent? 12. And it equals 3x squared. Now, folks, 10 to the 12th. If I could get that many YouTube subscribers, that would be awesome. But I don't think that's going to be realistic, okay? Yeah. Well, that's what I got you guys for, man, because I'm getting a letter of recommendation, and you guys are going to give me the 10 to the 12th subscribers.
I got a great idea. Give us extra credit on the love we put on our Snapchat stories. Like, that's how you get some subscribers. Just saying. Just a thought, you know?
I let you use your notes on the vinyl, except for that kid over there that doesn't know it.
But every Snapchat.
Look, you've been doing that, so you got to do what you got to do.
Oh, man. I've been over backwards, man. Okay.
You can buy subscribers.
Okay.
Yeah.
That's like what we do for clothing.
Okay. Trying to help people, Pat.
Make a diss track with another teacher. It'll go crazy.
Okay, 10 to the 12th over 3. And then, of course, what are you going to do after that? How do you get rid of the square? 10 to the 12th, that's a huge number, right? Your calculator says 1 times 10 to the 12th power because it's a big number. Divide by 3, it's still an exponential form, and then I can take the square root, okay, and we end up with $577,350.27. Yeah. Oh, sorry, I was thinking of, YouTube revenue. Someday, I'm trying, man.
Tell you, make a diss track on a teacher, post on your Facebook.
I can't do that. Maybe.
Make it a big deal, please.
No.
I will help you. He's a business teacher.
Okay. Notice that we have the same base logarithm on both sides of the equal sign. So if the logarithms are equal, and this right here guarantees that they are, and the bases are the same, what do you know about these two arguments? They are the same. X equals 5? What? Oh, 6. Okay, all right. Yeah, folks, it's that easy. It is definitely that easy, folks. When you have two logarithms, same base on both sides, you know the arguments have to be the same. Don't waste your time sitting there going, what should I do? Okay, it's set the arguments equal to each other and solve. It really is that easy. Okay, now, is this a single logarithm? No, it's not. So you need to make it a single log. Right? Okay. Who sang that song? All the single logs?
This is why you don't.
Who sang it?
This is who you don't.
You're so kind. I know it.
He's just trying to help us.
He's just trying to help.
Just trying to make you channel that.
Okay, so hopefully you saw the subtraction and you said, hey, I need to divide those arguments. So what would you put in the numerator of that fraction? X plus 10, right? And what would be the denominator of that fraction? 2. Right? You're just taking the first one is your numerator, the second one is your denominator, and of course the other side already was a single log. Sorry. I need to scooch this over.
Oh,
Nice.
please. Shoot
That was
for
a
me.
good
Come on.
trick.
Come on.
That was a good trick.
Oh.
That
was my
These are all packaged.
I'm about to say, everybody got a pass.
Everybody gets back.
Okay. So what do I do here? I've got two logarithms, both base 10 on, and they're singles on both sides. So what do I do with this and this? You're going to set them equal to each other, aren't you? Because just like the last one, now 4x plus 2. Folks, a lot of you struggled with the idea or thinking through. I asked you, what do we do to solve this? And some of you were struggling with it when we did it in class. So if you look at it as a proportion, because anything can be divided by 1, what do? You cross multiply, right? X plus 10, 8x plus 4, right? We're just multiplying on both sides, cross multiplying like we've done for decades. Okay. Okay. Move that to one side, move that to the other. Okay, so how many x's do I have on the right side? 7 x's. And if I take away 4 from both sides, 6. What does that leave me for x? 6 over 7. Right? Because you divide it by 7 on both sides. Okay. Are there any questions that you have over any of these things in 8.5 or 8.6 that you want me to go back to? Okay. Please make sure you do not forget your notes on the final exam. Do you have a question?
I go to the bathroom.
Ooh.
That's sad.
Here, you write this down.
You write this down. Teach them live, baby.
Yes.
So is it Mr. Staley with the name, or is it teach them live? You know, like that. That's creative.
It is creative.
He's got a
Oh,
whole
that's-
website out here.
Sorry, that's my website. I'll go to YouTube.
Flex. What a flex. I just got
Let's,
How many subscribers you got?
48.
126.
Yep. And as you can see, I put our videos on there. So yeah, I need to get over 1,000. So you help me. Oh, come on! You want that letter?
Whoa, whoa, whoa.